What we're talking about today is accelerated finishing with MASTERCAM 2018, and this is a topic or a term that you're going to be hearing a lot more of from MASTERCAM, and it's a really innovative approach to drastically shortening the cycle times that are involved when running finishing toolpaths. Everyone's aware of the advantages that were gained by the dynamic motion technology. The dynamic roughing, OptiRough, being able to utilize the full cutting edge of the flute while taking advantage of radial chip thinning. Really good stuff when it comes to roughing material away, but when it comes to finishing, then you have to kind of slow it back down or put it more in a reasonable feed and speed to make sure the finish is right. So MASTERCAM has partnered with Emuge in developing this technology, and it means we're doing. Emuge is the tooling provider that has these tools that you can use that we'll talk about today. And MASTERCAM, of course, developed the means of being able to use them to their advantage. So, and when I'm talking about finishing, what I'm talking about today is toolpaths where you normally would be using like a ball end mill or maybe a bullnose end mill to do 3D surface finishing. And when you're doing that, you're dealing with taking step overs, and that peak that is left between each of the step over passes is what we call the cusp height. So the lower you make that, the better surface finish, but that means there's more toolpath involved. So we're going to talk about the concept of using a smaller tool versus a larger tool. So here what we've got on the left is just a simple representation of, we'll say, a 4mm tool. That's approximately 0.157 in terms of inches. You can see that we've stepped over a set amount, and you can see the cusp height is higher than if we used a 25mm ball tool that we show on the right, the larger radius, so the cusp height is lower. Pretty simple concept, and when you look up close, you can see the difference. That larger tool gives you the better surface finish because there's more radius to act against that area in between the step over, give you a lower height. Well, if we use a smaller ball tool like we're showing here, we're profiling around a blade. The pros of it's easy to program, and it reaches into the tight zones relatively easily. The cons against it, though, is you have to take a small step over to get that good finish, and you have a long cycle time from it as a result. Now, if we use a larger ball end mill like we're using here, obviously we're going to get lower cusp height in between, but the cons against it is it can be a little more difficult to program because you've got other features that you have to watch out about running into. I mean, here you can see that we're clearly violating into this feature over here, and there's a lot of collisions and things like that. So it causes issues trying to use a bigger tool. So that's where this accelerated finishing comes into play. The accelerated finishing is where we can get the best of both worlds. We get the advantages of using a smaller diameter tool, but have a larger effective cutting radius to it. So that's where the circle segment tooling has come along. And we've got some examples here we'll talk a little bit more in depth on. And like I mentioned, that these cutting tools are made by Emuge. I'm sure we're all familiar with Emuge cutting tools. So let's talk a little bit more about it. The 3D surface machining, it's always a compromise. Do you want a better surface finish or do you want a better run time? You got to find that balance in between. Well, obviously to get a better finish, you're going to have a longer cycle time. But if you want to go and get a shorter cycle time, now you've got harsher surface quality to deal with. So, lots of other factors, obviously. So this new circle segment tooling is how you, the customer, the user of MASTERCAM can utilize these tools to your advantage and get the better finishes along with a shorter run time. So let's go ahead and talk about the different tool types of circle segment. We've got 4 different ones. We've got oval, barrel, lens shape, and taper form. Well, the oval form, you may have seen it in the tool types on MASTERCAM, there's that new tool type that's been in there for a couple of releases called the barrel tool. So it's kind of like how the name implies, it's barrel shaped. So that's what we see with this tool we've got right here that I've got my mouse around. It almost looks like a bullnose, but there's really a large side radius to it. It's almost kind of hard to tell by looking at it visually. Basically a barrel shape. Now we've got a taper form like we've got here where it looks like a taper end mill, but the side of the flute actually has a large radius to it. Then we've got the lens shape. So that one, just imagine a flat end mill, but with an oval shaped bottom to it. Where it has a large radius to the bottom. Just visually looking at it very quickly, you may just take that for being like a bullnose tool, but it actually has a very large radius on the bottom. And then we've got the oval form. That's where we've got something that we already talked on that barrel shape, all this type. So it's all these tool types are meant to give you the advantages of using circle segment in the various scenarios that you would run into. So we've talked about the 4 different types already. Let's talk about how this works. So this is a nice visual to give it to you. Imagine that we're profiling down the side of a part, like we show on the left with the ball end mill. The cusp height, it's going to be determined by how much we step down along that surface per pass around it. Now on the left, or on the right, now we've got a taper form of the circle segment. And so what we're doing is putting that cut to be kind of near the middle of where that taper zone is, but there's that really large side radius to that tool. And what we're going to do now is step down further per pass. And that's just, visually this ought to help it kind of make sense, is that obviously we're stepping down more at a time, we're going to get done faster now and still get the same cusp height that we would get with a ball nose and that kind of thing. So you can see that, what we on the left is basically like a 3/8 end mill or 10 millimeters. And then we've got the tool on the right where it's got that large side radius to it. We'll talk a little bit more about those tool types in a bit. But the thing with these tools is, this is where MASTERCAM came in. You can imagine if your only options were using a ball tool or using a bullnosed cutter, it could be a little difficult to program for these types, trying to take into account how this works. So that's where MASTERCAM has come in to support these. And these tool paths, these methods are supported in all the 3D surface machining tool paths and multi-axis. So we're going to talk some more on that in a bit. So these paths can be used on, obviously they're ideally suited to a 5-axis machine where you can vary the tool axis throughout the cut as well to keep it up on the tool in the right zone, but it can also be applied to 3+2. So you guys out there that may just have a 3-axis machine, depending on the type of part and the surface geometry needing to cut, you have this ability to use these kinds of tools and get take advantage of this. And I'll point out, those of you that are current on MASTERCAM, you're current on your maintenance, you've got this ability right now. This is in MASTERCAM 2018. If you're not on maintenance, maybe you've been on a version of MASTERCAM that's a little older, if you want to get back to current where you can use this, be sure to let us know. The MASTERCAM team here would be happy to speak with you on what it would take to get you back up to speed to be able to use what we're showing today. So when it comes to 3-axis machining using these tool types, really the best tool paths for it are going to be either using waterline or a raster cut. Waterline cutting is where if you're using a barrel form or a taper form and you're doing a surface that's mostly steep, basically doing the walls around a part, waterline will help you maintain a steady Z level of cut. And if you're using a lens form like we're showing here, again, like I was saying, it looks like that's a flat bottom tool. That's really a large radius bottom, and you can see the surface quality we were given from it. It's emulating the effect of a really large diameter ball end mill. That's where the raster tool path comes in to help you take advantage of that. And what I'm talking about, for those of you that may be newer to MASTERCAM, or maybe you've never dealt with multi-axis, when we talk about 3-axis or 3 plus 2, all we're referring to is the part not moving at all in rotary axes, but just holding steady while X, Y, and Z do the work. That's where we set a tool plane to set the lane of it. When it comes to 5-axis tool paths, like I was saying, this is where it's ideally suited to give you the full advantage of these tools. The morph and the parallel tool paths are really the best strategies. Basically morph between an upper and a lower profile, or from a left to right. And if you're working with a mostly steep pattern, the parallel tool path helps you to maintain that steady Z level, effect of cut. So when you are working in 5-axis, that's where the tool axis control that you use will make a big difference. You have to make sure that it's set to maintain that cutting edge relative to the surface you're cutting. And the way that we do that is, and I'll show you in a live demo here in a moment. On our tool axis control tab, we've got our output format set to 5-axis, and the tool axis is set to be controlled, with surface with lead lag. And what that's telling it is whatever surface that tool is cutting on at that moment, its tool axis is going to be determined by where it's contacting on that. And you can see that we can give it a tilt angle to hold relative to where it's cutting. So that's how we put the face of the cutting edge, relative to the part the way we need it. And you can also control for the lead angle. That might be handy if you need to keep from colliding with a certain feature on the part. But it's mainly this tilt angle. This will be what you really use to control for this. And like I was saying, that side tilt angle, that's how you set a set angle of contact on that tool to help it maintain that cutting edge where you need it, truly cutting at. So the result of this, what we've got here is a comparison showing the same part geometry on the left and on the right. On the right, that was cut using a ball end mill, and the step over was set to maintain a cusp height of 1,007. That's just so we could get a quicker runtime. But you can see our surface quality, that looks pretty rough. You look on the left, utilizing that same step over, we got a cusp height that was almost, just barely 2/10,000 of an inch, and you can see the difference that made in surface quality. The cut time to do that, 4.5 minutes. I mean, that's pretty crazy, because I don't know what the runtime was on this, but I've got a good live example to show you that really makes it stand out. I mean, that's almost like regular 2.5-axis profiling. Huge difference in time it made on that. There's a little closer in look at it. Anytime you do these kinds of tool paths, obviously when the part is completed on being machined, it's going to come down to some detail work, having to sand on it, do some polishing. It's pretty obvious that part on the right, you're going to have to spend more time on that than the one on the left. So on the right, longer run times, longer detail times. On the left, shorter run times, less detail work. So let's go ahead and have a look at how this truly works for us. So I've got a part file already in MASTERCAM, and I've already done some work on it. Obviously on these kinds of parts, I wanted to get a true, case study. If I were realistically running this part, I set my, I've got a three-axis tool path that we've got right here, where I'm using the hybrid tool path, and it looks like it's solid blue, but when you zoom in really close, you realize that blue, that's actually each one of the passes going around using a ball end mill. I mean, if I were cutting this part, this being a mold, or mold core in this case, I need to have good surface quality. So let's take a look at what I've set up in here. We go and look into the parameters. Let's look at feed and speed. We're utilizing a 1/2-inch ball end mill for running the speed wide open on RPM, and maintaining a 2 thou and 2/10 chip load for running at 80 inches a minute. I know at this point we're finishing. I could probably run a little faster, but again, I just find that when I'm using a half-inch ball end mill, running at 80 inches a minute, and then running at a step over, we'll point out we're running a step over of, I don't know why this changed here. It was at 5 thousandths and a 3D step over of 5 thousandths. So this is what I've used to get that nice slick finish. Now, when you get the running on the machine, how long is this going to take? Well, let's go check it out in our toolpath simulation. So we'll jump into this real quick, and what it tells us on cycle time. Let's see where we're at with that. So over here, 2 hours and 4 minutes. That sounds about right. If I'm running this part, I expect it's going to take a while to get that surface run. So, if you're the machinist, that stuff is pretty fun because, hey, you're not having to work your tail off. I mean, you get it running, and now you've got 2 hours and a few minutes to just sit there and watch it run, or maybe take care of some other tasks. But if you're the business owner, that's 2 hours and 4 minutes that machine is only going to be working on that. So this is where the circle segment tooling has come along to really help out on this. So what I've done is this morph tool path beneath it. This is a 5-axis path, and you can see the step over is a lot further than what I had on the hybrid. Now, I didn't just guess at this. I wanted to make sure that I get the same surface quality that this ball end mill would have yielded. So what I did, I created a little Excel sheet, and if any of you want a copy of this, I'll be happy to send it to you. This is just a simple Excel sheet where I plug in for the radius of whatever traditional ball end mill or bullnose cutter I'd be using, along with the step over I use. And it determines what cusp height was yielded as a result of it. So once that cusp height's determined, I use that to figure out what step over I need to run with the circle segment tool to get the same result. So you can see here, I've got a circle segment tool with an effective radius of 7 inches and 8/70. It's like, wow, you do the math, that's like over a 15-inch diameter ball end mill. Pretty unrealistic, right? Well, when we look back in MASTERCAM at this morph toolpath, what I've done is I've gone ahead and I've downloaded, from mastercam.com, the Emuge circle segment tool library, and I'll show you where to find this in a bit. But out of that library, I went and I selected this tool that we've got right here. So if I go and slide it over, you can tell by the naming convention on it, it's all in millimeters. But you see that there's that number 200 right there? Well, that 200 is telling me what that effective cutting radius is. And if you do the math and convert that to inches, 200 millimeters divided by 25.4 millimeters per inch, that means that radius of the tool, it's on this taper form, is 7 inches and 8/70. So wow, let's go and plug that in. So that's why I've got this sheet here. And if I plug in that effective radius, it tells me that if I want to achieve the same cusp that I'm using with the ball end mill method that I know gives me what I want, it tells me I need to step over 28 thousandths and 1/10 per pass around. So you think about it, that's over 5 times more step over than what I was giving with the ball end mill. So that's what we've done. We've got the same feed and speed on it. And you notice that the feed per tooth is actually a little less, so that means we're going to get a little better surface quality. But we go and look at our cut pattern. You can see that for the step over, that's what I've plugged in, 28 thousandths and 1/10. You notice I've set this realistic. I'm not loose on my tolerances. I mean, I've got a 2 10/1000ths cut tolerance. That's what I find gives me a great surface finish. Like I'm saying, I want to emulate what you would have to deal with to make your parts right. So we were at 2 hours and 4 minutes with this method. Let's see where we're at with this morph method utilizing circle segment. So look at that time difference, 23 minutes. I don't know if you can see this. It's on the right side of my screen. I'm waiting for the model to come in. but you know, how much is that? That's almost like a decrease of how many times? You know, 4 times. That's like a 75% reduction in cycle time on this, while still yielding the same results. That's really cool. So I'll talk a little bit more about this. Now, obviously, I had to use a 5-axis toolpath to get this run, and the reason I did that is so that when I go and I backplot this tool, you can see that by looking at it, you know, I've got that nice taper form, and it looks like a flat, right? Well, remember that's that 7 inches 870 radius. I apologize for that. Let's slow that down a bit. You know, what I've done is I've set this toolpath up so that as it's running, you know, it's slowly morphing from one contour. I chose the top edge of the funnel down here to the bottom of the part. So it's almost kind of like a lathe in a way. It's like it's just continually transitioning its way from top to bottom. You know, it's, you know, if you guys have MASTERCAM 2018, you know, Mill 3D, a lot of you have multi-axis, a lot of you guys have invested in multi-axis machines. You can do this. This is what this new technology has given you in MASTERCAM. So definitely take advantage of this. Check it out and put it through its paces to help you improve on your projects. So let's go ahead and talk a little bit more about this. Let's jump back into here. You know, how do you start using this? I know that's probably the next question you guys have is, okay, you know, where do I get that tool library from? Where you find that is on MASTERCAM's Tech Exchange. So I'm going to toggle over to the internet real quick. Let's see. Let me find that. So I'm just going to show you live how I go and find this. We'll go to mastercam.com, and a lot of you have logins to get onto this, but I'm going to go and log in, show you where we find this. And let's try that one more time. A little bit of trouble there I was having, but anyway, once I'm logged in, I go to the support tab and I go down to Tech Exchange. So when I go into Tech Exchange, of course you can filter up here if you want, but it may already come up for you down here. If you scroll down, you can see that you can select from either sample files, tool libraries. You can download posts from here, as well as other plugins, but you just kind of scroll through here. See, there's all kinds of different tool databases that are available, but if you want to find this a little bit more quickly, just remember that these tools are made by Emuge, so I'm going to type that in. Filter down to that, and this is what we got. First of all, we got the trochoidal tool database. That's for the dynamic cutting, but this is what you're looking for. The Emuge circle segment tool database, and you just simply download the zip file, and what's in that zip is just a simple tool library file. So we'll go back in MASTERCAM where I've already got this tool database file. We'll have a look at it. So go to Tool Manager. I'm going to just have it show just our library tools for now. But what I've done is I've navigated to where I've put that circle segment tool database. This is what we've downloaded, and this is what it is. It's just a real short and sweet tool library. But you can see if you look at these, I'll just pick one here for instance. Let's take this barrel form right here. We'll go and edit that tool. So go and look at it. It's already preset to what Emuge's designed this tool to be. See, there's a lot of data that had to fill in, and you have to be accurate on this for this toolpath to work. Don't worry about doing all that work. Emuge is already partnered with MASTERCAM on making this library available to you guys. So there's all kinds to choose from. You can see that we've got the oval form like we just shown. We've got the barrel form. Look at this. Looks kind of the same. Let's look at a lens form. So you look at this. This is where I was talking about. This is what you would use, like if you need a tool to be almost perpendicular to the surface, like if you're working down inside of a deep cavity on a kind of a concave or convex surface. You know, you can't put hardly any side lean on it. This is where we can use the lens shape for it. We've got other ones in here like this taper form. Look at that. You know, this is one where you can have the tool held at a side lean of a certain amount of degrees to keep it, you know, right about the middle of this effective cutting radius we've got on the side, and they have it in different angles. You know, that was a 20 degree. Let's look at the 60 degree. You know, this one's a lot more leaned over. Almost looks like a chamfer cutter when you first see it, but remember it has a large effective cutting radius along that edge. You know, this one you can use in different, you know, scenarios where you may be deep inside the cavity, but you don't want to be on the lens shape because you don't want to be too perpendicular. Well, we've got this one to take care of that, and we've got various other ones in here. You know, my advice is just check out what Emuge has to offer. You know, and I'm sure you guys have sales or tool sales people that you can speak with on it to advise you on which one would be best for your application. But once you've gotten that chosen, and now you need to actually create a tool path utilizing it, well, you know, MASTERCAM has got you covered on this. So, you know, like I was saying, you know, on this webinar today, it's not really a very long webinar. It's a really simple concept. You know, just the idea. It's one of those things I wished I'd have thought of. But you know, the dynamic toolpaths helped you, you know, gain a lot of improvement in cycle time when it came to roughing. But then when it came to these 3D surface finishing toolpaths and 5-axis surface finishing, you're just kind of, you know, to get a quality finish, you just still had to run it at a reasonable feed and speed and step over. This came along and changed the rules on that. So that being said, I'd like to open up for some questions. And for any questions you have, I'm watching it right now. There's a question section in that GoToMeeting control panel. If you minimize it out of the way, just re-expand it. But go ahead and let me hear some questions. Now, I do have one question. It says, if you guys can't hear me, let's check this real quick. If you can hear me, click that raise hand button. I want to see, okay, I see one raised hand. I see several. Maybe make sure that your speakers are on. Work with that. See if you can still hear me at all. Okay, it's fixed. Okay, any other questions? Let me break this out so I can see it a little better. Just a moment here. Yeah, so you know, the question is, are these tools only available from Emuge, or do other manufacturers make them as well? Right now, the you know, Emuge, as I understand it, is the only supplier of these. I wouldn't doubt in time we may see some others get on board, but Emuge is the only one that I know of. Got Stephen Miller. Yes, I'll be happy to send that Excel sheet. Send me your email address, as well as anyone else. I'm going to copy and paste them into a notepad file on this end to send these out. The funny thing about that Excel sheet, I actually made that this morning when I came in, because, you know, there's some toolpaths that you notice, like on the 3D toolpaths, you have the option to specify it as a step over or as a Cusp Height. But if they don't have a Cusp Height option, then this is where you can get it. So I see lots of email addresses coming in. Great. Another one is, I missed the first part of the webinar. Where can I go to review parameters and toolpath options? Well, you know, that's where, you know, we just go back into MASTERCAM and let's close this out. I hope this answers your question, but what I did, I just created a 3-axis, you know, finishing operation using a ball end mill. You know, parameters, I'm just looking at what tool I've selected using a 1/2-inch ball. I'm looking at the feed and speed that were assigned to it, mainly the feed rate. And and I'm also looking at what step over was given to it. So that's where I took that data and figured out where to go and put, figure out what the step over would need to be to get the same cusp height. I hope that helps. Can you go over the tilts? Where'd it go? Okay, yeah. Can you go over the tilt angle at side of cutting direction field again? Okay. Yeah, so on this morph toolpath, I'm using a taper form, and notice it says 70 degrees. So to put that cutting tool running, to put that right in that zone, it tells me I need to be, tilted over at 70 degrees, or actually I need to have it, I need to find, the other component of that angle. So here's the thing. On tool axis control, when you go to create these toolpaths, the lead angle and the tilt angle, they always default to 0. Well, if you do that, it's going to run the tool perpendicular at that point of cut. It means we're going to be running the tip of the tool. We don't want that. So I plugged in a side tilt of 20 degrees. I just got that by taking 90 degrees minus 70, the taper of that tool, and that puts it right in the middle of that sweet spot of where it runs. And then when I do that and I back plot it, bring this in real quick. You can see as let me just drag it around. Let's get a little bit lower. That's how I'm maintaining. If you imagine the center on that tool, it's at 70 degrees, or 20 degrees actually, to put it right in the middle of that zone. And it's going to remain steady throughout that cut. I mean, as it works down the top side, it's running like that. And then we get a little further down into that surface. That surface is obviously at a different angle, but it's still maintaining that 20-degree lean relative to where it's cutting on that surface. Of course, this is multi-axis. If you guys have multi-axis, you've got this ability right now. But if you ever wonder what multi-axis can do, this is one of the many things that it gives you control over. So let's see. All right, so we've got some others asking for the Excel sheet. See what other questions do we have here. Cusp preached. Thank you for Excel. It's in that spreadsheet. Do you have any examples where these tools could be used in 3-axis profiling? I certainly can make one real quick. Let's just do that. Let's go and make something up on that. So save that real quick. We go File, New, and I'm just going to draw from my right plane. Let's go and draw something real simple and basic. Let's just draw a rectangle, and let's make it interesting. Let's go and put a little bit of a radius on this. So I'm going to say create an arc tangent at that point. We'll keep that arc. Let's give it a radius of like 2 inches. And let's say that you got a part, you've got a machine like this. You got to cut that edge on it. So once I've gotten that done, I'm going to create a solid extrusion. Keep in mind, you guys have ability in current MASTERCAM. You can create solid models and do model prep. So let's just say that this is what we need to machine. Let me set my planes properly here. And I need to cut that profile on, right? Well, let's go to machine. We'll pick a machine type. And let's just use something real simple. Let's put a flow line cut going down this wall. Set our flow line parameters. We want our rulings to run that way. And to get best results, I could climb cut, but let's just zigzag cut. Let's keep this simple for now. So that's what we want to cut, right? Well, let's go and get one of those Emuge barrel tools that we had seen. Or create. Let's go and pick from the library. So we're going to switch over to that Emuge library. So imagine you're at your job right now. You're going to download this library when this webinar is over. You're going to get this set up, and you've probably got a part you're thinking of right now that you can use this on. So man, that's where it starts to get fun. Let's choose that barrel form. I may just double check. Let's see what the form is. Oh yeah, that's perfect. That'll do great for this example. So we've got that. Let's give it a feed and speed 12,000 at 80 inches a minute. Got all these parameters set. Let's give it a nice high retract just so we don't have a collision. And on our flow line parameters, yeah, here we go. So before I would put like a distance of 5 thousandths, you know, this one you don't even need that Excel sheet on. Let's just plug in a scallop height of 1/10,000th of an inch. Click OK. Tools. Yeah, I should have done a little differently than that. So you know what? Let's jump back to our calculator. Let's see what that tells us. And I must have closed it out. So let me go open that back up real quick. All right. So you know, utilizing, you know, just since I'm using a 1/2-inch ball end mill, you know, this is what I've determined is a Cusp Height. So let's take a look at what this tool is. You know, going by the naming convention, that radius 50, that means it's got a 50 millimeter side radius. So let's do our math real quick. You know, 50 converted to inches, 1.9685. So 1.9685. Says I need to step over 14 thousandths at a time to get that 1/10,000th cusp. You think about using a ball end mill stepping over 14 at a time, that's pretty drastic. So just plug that in. That'll give us what we need. Looks like a pretty coarse step over, but it's going to maintain that nice 1/10 cusp that we want in between. So yeah, I mean, there's a simple example in you know, utilizing the circle segment and 3-axis. Hope that helps. Let's see here. What else do we have? Sheets. All right, so we got that one. Let's see what other questions we have here. What are the best way to utilize these toolpaths with 3 and 4 axis if no 5 axis is available? That's a great question. So what you would do is, you know, if you're on a 3-axis, you're going to be kind of limited, you know, in like if the surface has a lot of degrees of twist, or it goes, you know, from being mostly a steep surface to more of a mostly shallow. You may have to kind of combine different tool types to get the same result. But if you're on a 4-axis machine, you got a little bit of an advantage because you can tilt, you know, if you're going to do a 3+1 method where you're just going to move the part to an index that puts it within range of where you can take advantage of the particular tool type you got. And then if you do need to run, you know, simultaneous 4-axis, you know, you'll notice that back in that file, let's go back to that file that we're just in. So, you know, if you have MASTERCAM multi-axis and you have that add-on, you know, you do have the option on the tool-axis control to limit it to just running in 4-axis output. So, you know, obviously you'd have to have your part set up in a manner that holds it where it can be, you know, effectively cut like that. But, you know, multi-axis, multi-axis doesn't just apply to only people with 5-axis machines. If you have the regular, you know, the commonly found 4-axis vertical machining center, and that 4-axis machine is able to cut with 4 simultaneously, meaning that it's on index axis. But if they can cut simultaneously, then you can use multi-axis and use these tools on that type of machine. So let's see, there's another question here. So does MASTERCAM 2018 support creating your own oval form and lens tools? You see barrel and tapers, but not oval or lens. And you're correct. So answer is yes, you can. We'll take a look at that. So if we go look back at that Emuge library, let's just take one of these lens form tool types. If you look over and you look at the type of tool it's been defined as, they actually define it as if it were a high feed mill. So if it's a lens form, you would define it like it's a high feed type. Let's go and have a look at it. The way that is done is, you know, when you're talking of high feed, you've got the lower radius component. That would be the form of that lens. And then you got the upper radius component, because there's going to be some kind of a corner radius in between that, you know, you're really not going to be cutting with, but that's where you plug in for that corner radius. So that's how you would do a lens type. If it's a taper form, you actually define that as if it were a taper mill. So we go in and let's have a look at that. You know, you notice that there's only one radius field, you know, a radius of 0.439, but you don't see one for that form radius. You look up a little closer, it actually looks straight. Well, on Emuge's library, when you know, by default, like when you pick one of these tools, it's defaulted to showing the rendering of the imported tool versus the MASTERCAM tool. If you switch back to a MASTERCAM tool, it just looks like a regular MASTERCAM paper end mill. But when you look at the rendering of the imported, that's where it has that radius already on it. And when you've got it set to this and you go to run your toolpath simulation, you know, that's what it's going to be showing as the cut that is yielded from it. Now, I know you may think, well, is that really going to realistically help us hit what we need? And you know, the way I can tell you, just go and have a look afterward. You know, let's say if we just fast forward it all the way to the end of the cut. I don't know how long this is going to take here, but after you've gotten it fast forward to the end of the cut, you can go to your verify tab, and you know, there's that compare feature. Just put it in comparison, and then on your tolerances field, just set them at what your real tolerances are, and I think you'll see that it's almost like right on. Really will help you out a lot on this. So let's see here. Got some other ones here. Can you send a copy of this recording? Yes. This whole webinar is actually being recorded right now, and when it's done, it'll be handled by our marketing department. They'll get that big stuff, and they'll have that available to watch online. We'll probably send you look for LinkedIn posts. We'll probably go and show you. Or we'll probably have it on LinkedIn so you can click it. People can check it out. Just want to thank you guys again for attending. I hope this has been informative for you. You know, I hope you've been able to really take a lot from this. And I'll tell you, for me, it's like at first I didn't really think much of it. I saw barrel tool types. I was thinking really that's just like more so for maybe cylinder head porting. But when I saw this demonstrated by CNC software, it's just kind of like the gears really start turning in my head. And I was like, wow, that I can see how that can help out so much. So yeah, you guys that are current on MASTERCAM, you have a surface machining, and you have multi-axis too. You guys can do this. Go check it out. Or log into mastercam.com. Get that tool library and start putting this to work. This is another ace in the hole for you to succeed against your competition. But that said, we'll go and wrap this up. Thank you for attending, and we will be talking to you guys soon about other webinars and events that we have.